Good day, ladies and gentlemen. Yes, welcome back to another session of information about mechanical drawings. Remember, we have done the mechanical analytical questions. There's a lot of important information that needs to be understood by the learners when it gets to mechanical drawings, and it's not only focusing on mechanical analytical and mechanical drawings. It's a combination of all these drawings, right? So therefore, I will explain to you, once we're done with this session, mechanical analytical question papers as well as mechanical assembly question papers, because it can't be seen as separate different drawings. It is shown, it must be seen as a unit for mechanical drawings itself. Right now, mechanical assembly drawings just tells you it's been assembled. It needs to be 2 or 3 or 5 components. Now in grade 10 level, you only have got one component to draw and to section through. Now for grade 11, you will have 2 or 3 components where you have to assemble those components into one another, into a unit, and then from there on present it to the examiner or present it to the machine maker, the model maker, whoever is going to work with that as a unit, combined and assembled as a complete drawing. Now if you take a look at the slides itself, mechanical drawings. Now once you start drawing a mechanical drawing, it is important that you will have to fit in your drawing onto this part. Now this is the front view. It's been given the front view, the top view on top here, and the left view on the left hand side. Now the examiner is asking for a right view, front view and a top view. Right, so we're going to have a front view, a top view, and we have to have the right view over here. Now this is like a cutter for cutting wire, or it's a cutter like cutting biltong or something like that, where you've got a knife or an edged blade over here, a handle on this side, and you've got your nuts and bolts over here to join this part over here as a unit, and to get a unit of this part over here. Right, so now this drawing consists of a width or a depth, if you can see it that way, and a width for the left view, and also for the length of it from left to right. In other words, it's also called the width of it, and then the height of this part over here. Now this is like a drawer. If you pull out a drawer, it's left to right, it's the width of it, how wide is the drawer, how high is the drawer, and how deep is the drawer. In other words, how deep can you put your hand in, and that's the depth of it on the top view or on the left view as well. Alright, but now I have to fit this in perfectly so that it fits in on this clean page of mine. So how do I go about in terms of finding a center point to be able to put and to place my drawings in such a way that it won't run out of the page? In other words, if I start drawing it, the front view goes into the wording of it, or maybe runs even worse, runs off the page itself. Okay, now I think the most important part is you should know where to place the front view, left view and top view. What's the examiner is asking, and you have to remember that this is third angle lithographic projection. It tells you, you look at it from the side, but you will go back on your track. So the left view has been placed on the left hand side, but now it's asking for the right view, so the right view will be placed on the right hand side over here, top view on top, and this will be the front view, the anchor of the drawing. Okay, so here we go. Should we take the front view we have to fit in over here. The top view we have to fit in over here with all the dimensions, and the right view should fit in on the right hand side over here. So if you take the width of the front view, in other words the length from left to right, it has to fit in some sort of way into this whole complete drawing. So there we go with the front view. I know if I place the front view on the sides, on the edge of this frame, it will fit in up to that point over there. I know I have to do the right view, so the width of the right view, or the depth of this drawing, in other words, will fit in from this corner or frame line. It will fit in all the way up to that point. But now obviously we're not going to present the drawing where it's all fit in into the corners. We want to have it in the middle of this part over here. So what will we do with this space left open is basically we will measure that, and then we will divide this area by 2 to get the halfway mark, and then to get the drawings apart from each other so it doesn't stand next to each other but some space between them. We're going to say let's go 10 millimeters to the left and 10 millimeters to the right on either side to find the start position. So if I put this corner now, this portion of this part, that specific corner, in that corner over there, it means that this open space will be on this side over here. And if I put this exact point of this drawing over here, that point from there onwards, it means that this space, this open area will fit in on that part over there. Alright, so there we go with that part. Now, of course, we have to have the top view on top of that as well. So again, we've got an open space. We can divide this into two, and we can have 10 millimeters on either side. So that's the halfway mark of the open space or the open area. And we can go 5 up and 5 down, or in this case 10 up and 10 down. So now we know we have got the start position. So if I start with that corner in this specific spot over here, the top view will fit in over here, this open space on the top, this open space on the bottom if the front view moves in here. But now careful, because you can't start with that corner up to that point, because it's extending a little bit further onwards. So I have to take this into consideration when I place this view in. That is not going to stand exactly in that corner over there, but some distance away. That's the distance I'm going to measure. And the same with this. If this is not in line, if this is shorter, I have to start over there, because I have to compensate for this portion over here on the top part of that part over there. So I can't just measure. I have to go from the top downwards, and then from the center upwards to find how far it is going to be. So therefore I will go downwards to find how far it will go up to the top and to the bottom. Normally I will say start with the biggest components, and then after that build the rest of the drawing around that part over there. Okay, so in other words, that's going to be the space for the front view. Can you see it's not starting exactly on that line, because this is a bit higher, and of course this is extending further. So if I extend that line, it will intersect with that point at that spot over there. And if I go and extend this line over here, it will be going there. Doesn't mean that it's going to stand right on that point over there. Alright, so this is the way we're going to do the front view. I know the top view will fit in here. That's no problem over here. That's the furthest point, so therefore the top view will fit in perfectly. And now it changes because of the fact it's given me the left view, it's asking for the right view, it's saying those are all dimensions, diameters for handles and those type of things and so on. So if I look at it from the right hand side, I'm going to place it on the right hand side. So I'm going to take the right view, see what it looks like from the right, and place it over here. Again, the handle is much thinner than the base, so I can't start with the handle over here, then the base will be basically going over to this part over here. So I have to extend the base that it starts on that point, and then the handle will only start deeper in. Right, so that's the very first important part that you have to understand about assembled drawings. When I assemble this whole thing, it's going to take up some space in some other areas as well. Now this is consisting of 1, 2, 3, 4 components to the utmost, so it's not that difficult to understand. But now if you get a drawing like this one over here, it's consisting of a lot of components, and normally they will give me a 3-dimensional view somewhere on my drawing. Maybe I can just go out on this portion over here and pointing out to you, this is what the examiner has given me. Alright, so there you get the isometric view of all the components and how each one fits into one another. Besides this portion over here, these are all the components that will be necessary for the dimensions to be able to fit it in. And I'm not going to draw an isometric drawing over here. If you go through the question, you will see that the examiner is asking to you to draw a assembled drawing. Alright, draw to scale 1:1 in third angle geographic projection the following views: a half section front view. I will get to the half section just now on the cutting plane AA. The top view that you have to put in here, and then also planning is essential. This is the part that I've done just now. All drawings must comply with the guidelines with SANS. Again, the work that I've done with mechanical analytical questions will be applicable over here. So how do I draw a square on the shaft? How do I draw square thread? What is important about doing nuts and bolts, and what are those angles that I will find over there? And then also besides that, if it has got a square on the end like this one over here, it's been indicated but never said it's square, but I should know and I should have the knowledge that if it's corner to corner, it's a square and it's not round anymore. There's no diameter on the dimensions as well. So although there's dimensions M or diameter dimensions on this upper part of it. Alright, so if it gets to gears, again I have to know how to interpret, how to understand a gear, and how to draw a gear. Now the examiner was nice to all the learners and say, alright, if you draw a gear, this is the way that you will show it. Now again, giving you lots of information. There's the center of the gear going upwards and going downwards, and all the teeth of the gear itself. And then from there you got the center of it, and from going upwards and downwards, a part of it has been sectioned, other parts not been sectioned. So you can see it runs through the two different open spaces between the tooth. Right, so therefore there we go with this portion over here. Then you got a collar plate itself. On the bottom over here you got the sump itself. That's where the oil will fit in over here. If it starts turning, that will get lubricated the whole time. Then I've got a collar, I've got a pin, and if I don't know where the collar fits in, if I don't know where the pin fits in, go to your isometric drawing. It points out to you, there's the collar on the bottom, there's the pin goes right through. So if I take a look at the pin, I can see that there's some holes over here, and it correlates with diameter 6 of the pin. So the pin has to go through this part, but how does it go through? Over here on the shaft there's also again a diameter of 6. So most probably this pin will go here underneath, and then the collar will go underneath, and the pin will go right through everything in that regard. So therefore you have to, in your mind, try to figure out, this is going to be on the bottom, this is fitting in there. If the shaft goes through all those components, I have to put the collar in and to put the pin in so it doesn't fall out again. There's the cover, which is the cover over there. There's the bush of what I've shown you with the previous rounds. The bush is basically drawn here on the bottom over here, and then the shaft itself goes from top to bottom. So therefore this shaft most probably will fit in all the way through up to the top where this thing goes in as the collar plate itself. Now again, you can go and have a look. Diameters of 52, and if I go to the diameter of the shaft itself, it is 42, but with the bush in here it's 52. So therefore 42, the shaft will fit into the bush, and then the bush will fit into the hole of the collar plate itself. Alright, so that makes sense because there's the collar plate, 52 goes in there, that goes into that, and then the gear placed on top of this portion, and then you've got a washer, and then after that you nut it, put the nut on top there. Here on the bottom there's the plug that you have to put in so that the oil doesn't run out. This is the front view. Alright, so now since you've got this as information and you're familiar with what has been shown over here, I simply just want to start with this drawing over here. I'm gonna start with this portion over here. Now if you should take a look, I just want to make more sense about space over here. So there we go. Those are all the components that you have seen now that I've explained to you, basically placed on the same areas. Not all of that 100%. There's the isometric drawing over here, of which I can maybe enlarge a bit towards this part over here. So that is the isometric drawing to help me understand what's going on here. Alright, so let's start with this portion over here. This is the plug, and I used to say start with the biggest portion or biggest part of it. Now, okay, that is the biggest part, that's the sump. So I'm going to put the sump in over here on the bottom. Alright, now I know the plug runs into the sump plug. The sump plug has been placed over here now. Now, if I take, for instance, take this portion over here now, remember this is the cover plate that I will have, so therefore this is the cover plate. The cover plate actually needs to fit in on this portion over here. It goes in at that point, so therefore that's the cover plate. Now remember, I'm using a drawing that will be basically be visible as a partly sectioned area. Okay, so now this is placed in. I have to put this bush inside this. Alright, according to that, the bush will drop into this portion over here. There's the bush, so I can place the bush now inside this portion over here. So there's the bush now, it goes into that portion over there. Take the shaft, and I'm going to place the shaft inside over here. Now I just need to determine how deep I'm working with the shaft. Now the shaft goes up to that portion at that point over there. Now in other words, it's flat on the bottom, because if I put the gear on top there, it can't have open areas in that area. There's no washer in here, the washer is right on the top. So if I tighten the washer to the shaft, and I've tightened the nut to the shaft with the gear in between, it will be on the bottom bed of this gear, on the bottom over here, it will run on this portion of the shaft itself. Alright, so that's going to be up to that position of what I see over there. Alright, now before I can put this in, I have to take this collar, which is the blue one over here, which is this portion over here. This part will fit in on the bottom over here, so therefore it will go into that area. Now that's fitting in over here, so I will see with my dimensions how much of the shaft will stand out on the bottom. And I take this pin, and the pin goes in that portion, so therefore if I take the pin, it goes into the collar, it goes right into, and it goes right through to the other side. Now the shaft is also part of this, it's going into the shaft on the bottom over there. Alright, so now we can take the gear. Like I said, there's no washers over here, that's indicated. So in other words, I can take the gear, and I can place the gear on top of that part. So now it's standing onto the bush, and that's the purpose of the bush. If there's friction occurring, it's much more expensive to replace this part than what it will be for the bush. So therefore the bush will take all the hammering in that regard. Alright, there's the washer. So I can take this washer, and I can place the washer inside here. So there we go with that washer part. And now I can take the nut, and I can turn the nut in. Of course, I can't start with the nut by placing this nut in over here, because I don't know what the width and the size of the nut. So therefore I have to get an auxiliary view, and most probably the auxiliary view will be part of the front view, the top view itself. Right, so for this purpose now I've placed the nut in there, but you should know that the size of it will come from auxiliary view and not from this view over here. Alright, so in fact I was first supposed to draw the nut in at that point over there. Now you will see I've got an area that blanks it out, but we will get to that now. Alright, once we're there, we have to draw the top view. Alright, now what will be visible from the top view? If I look from above, will I see the sump? The sump fits in perfectly according to dimensions, exactly the same as what this sump cover plate is. Alright, so in fact I won't see the sump on the bottom. I won't see this part over here. So this information that was given to me on my exam paper was just for information on how does it look, and where does the screws and those type of things fit in onto this part. There's screws as well as bolts. Okay, so this part over here fits in over here. So I can say what I will see is basically this area over here. So therefore that is going to be the upper part, so I will see this portion. Then after that there's the bush, but the gear will cover the bush. So if I take the gear and I place it in over here, remember it's half a section, so therefore I'm not going to do the complete section or the complete part of the top view. So the gear will fit in there. On top of the gear I will see the washer. So I can take the washer and I can place the washer in here, halfway, it's more or less over there. So there we go with the washer, and then on top of the washer I will get the nut itself. Now remember, the nut is necessary for drawing the nut in the front view, so therefore I will use those dimensions to enable me to find the complete front view. Alright, so this is where we go with this drawing. So this area over here, this is the shaft. In fact the shaft will still stand out over here, so there's a smaller area of the shaft that will be, in other words, visible, that will be placed over there. Since the shaft will go right through this part over here, and this will also have a difference in the dynamics of this broken circle, of which I will explain to you in a few moments. Okay, and then there's some screws that's been placed over here. So there's the screw, and since it's going to be sectioned in half, I can say I can turn one screw in over here at that point, and I can turn the other screw at that point in on that side over there, and that might be visible. But now, since this is a quarter section, I will only see the open end over here, and I won't see this part over here. So I can take off the screw over here, because it's not going to be visible. It's going to be flat on the top itself. It's going to be tapered and it's flat, so you won't be able to see the rest of this part of the screw. I think it's a bit higher up, I can't remember. There's the screw itself. You can see the screw is flat, so it's placed in such a way that it will basically be on the top there, so I won't see any of that. But on this quarter section area, it will be visible in this regard. Alright, so this is the placement. This is how I'm going to place my views and how I determine where to fit in, and all these of course is not necessary anymore. Alright, so ladies and gentlemen, So what if you get your exam paper, you should then in that case see what you have, work with your isometric drawing, your isometric exploded view, work from a center line since you've got a dominant center line, and work from the center line and work from the parts that are basically the biggest parts to say, all right, I'm going to build everything around this part over here. And then of course, now the examiner asked for a half section, so therefore the half section should be drawn. If I maybe can quickly show you the memorandum, this is the half sectioned area. You can see this half is sectioned and this part is not sectioned. You can't see the screw. There's the screw being placed in over here, and this goes all the way around. Then you got your shaft that runs from the top all the way downwards. There's the shaft, it's enlarged over here. There's the collar being placed in. There's the pin that goes in there. There's a partly sectioned area over there. The collar has been sectioned. There's the bush for running in there. There's an open area, and this is the bush that will be visible on this side over here. Right, and there's the gear. Again, there's the symbol, the convention of the gear itself, the convention of the gear, of which the examiner helped me a bit with. And then I've got a nut and a washer on the top over here, and the part of the shaft that stands out here. On the shaft on the bottom, there's the shaft on the bottom, and then the last part I want to point out to you is the square on the plug, and then the thread. Now the thread, again, you can see the difference in line quality. I will explain that to you in this next few sections that I will get up to. Alright, so I will leave this page now. Just for one, before I leave this page, this is the upper part of the gear. You have to figure out where exactly the gear will fit in. Besides that, what will be visible? It's only the upper part over here that will be visible. It's not the complete sump that will be visible. So that is the upper part, and then I have to figure out where exactly. And then again, the convention of the gear, which is that center line that's been placed in there. There you can see the convention of the gear. And then the gaps that the gear is creating will show me some detail at some areas that is visible through this gap that I see in this area over here. Alright, and there's the nut, and then the shaft, and then the washer itself. Alright, more of that a little bit later on. Let me just quickly go back to the slideshow, which is this view over here. Over here, we have done this portion, we have done this, and there we go with this part of the mechanical drawing. So that is basically what you need to know. Now if you go to the construction of nuts and bolts, of course we have to stick to the rules, and this is what some people don't know, what a stud looks like, what a bolt, and what the difference is between a bolt and a nut. And so I will quickly go through this. This is your nut that you will get, what you will have to turn into the bolt itself, and this is what it will look like. This is what it, the edges will be shown to you. I will explain that to you just now. And on the left view, there's no edges in that case. Then this is the bolt itself. There's some sizes according to that, and then also then some detail that I need to know of bolts, and with a stud exactly the same. There's also some information that needs to be known. Alright, now what I will say to you is, in fact, that with a exam paper like this one, the examiner is always giving to you the diameter. In this case, for this plug, it's saying to you M10. So in other words, the diameter is 10 millimeters over there, and not necessarily will show it to you, but with the nut like this one, it will tell you it's a M20 nut. Alright, so what it say by M20 nut is basically then that you should remember that M is basically a factor that will be used for the diameter from top to bottom. Alright, so once it's there we go with the nut, and we will always work from M as the diameter. In other words, I will always be able to determine the size of the nut, the size of the bolt head, by means of diameter, right, by M, in other words. And there's the factor that I will always multiply 1.5. So that size, or this size, is always 1.5 of the diameter of my bolt. The thickness is also measured by means of the diameter, in other words, in this case, let's say 36, and multiply by a factor of 0.8. 0.8, in other words, that's the thickness of the nut itself. Then the thickness of the bolt is 0.7 of diameter. So, and then also the thickness of the thread will be 0.0 of diameter. So that it's very important to understand and to remember those formulas that we will be working with. Now, if I say, for instance, I've got a piece of metal and I drill a hole in here, if I cut through this, of course, it will be basically an open area, and then from there on you will see on either side the hatching, but no hatching in the hole. I believe you're going to be fine with this portion. If I put the thread in, what's the size of the thread? We said it's 0.1 of diameter, so therefore that's the size of goes inwards. Hatching will go through the thread because it's still metal, pieces of metal that are still in here and pieces of metal that are still in here. The moment I put the bolt in, the bolt is something that you don't hatch, so therefore there's no hatching. The hatching disappeared in the process over here, but there's still hatching here on the bottom, still hatching visible here on the threaded part of that area. Alright, so that's important to know. Okay, and then you got your washer. Normally we don't cut through the washer, so therefore the washer will be dominant, it will be visible. And then if we put a stud in, for instance, not the bolt itself, the stud will fit in over here, but the stud will stand out on the top end, and that will change the appearance of this part, because I will see the outer part, but inside the metal I will see the thread of that portion in that area. Okay, so in the case of a nut, there's an open end, and then the material will be basically cut into, the thread will cut into the material, so therefore there's the material part. So in this case, these two swapped around now from the previous exercise that I've showed you there towards this one over here, where this hole will be now the solid circle and the threaded part will be in the material part of the nut itself. So that's the broken circle in that case. Okay, so these are the principles. This one is now the bolt standing up and seen from above. I will see the outer part, that's why the outer circle is solid, and then the material will be cut for thread, so the material inside here will be a broken circle in that case. Alright, so we have to figure out what and when will this happen and how exactly it will happen. This is exactly the same as the previous one. The only difference is the bolt standing upside down now, and then of course it will make a broken circle on the inside material part of that. Alright, so there we go with a stud, like I explained. Construction of a nut, how do we start? Where do we start? Of course, we will have to work with the center line. We will have to take a look at diameter. What is diameter? In this case, diameter is 18. So there we go with diameter from top to bottom side of the shank itself. And I said the factor for determine the size of it will be 1.5. So 18 millimeters multiplied by 1.5 gives me 27. So I need to go from there, 27. Diameter, which means 13.5 to either side, draw a circle, and that's the circle for the hexagon that will fit around this part over here. So the hexagon will fit sweetly around this portion of the circle. All right, now I can say we can start with the diameter part of it. The diameter is basically 0.18, so that's the broken part of the circle. Just take care of that, because that's the nut. This is diameter, so the outer part to outer part must go inside the nut and inside the nut, and diameter will be from inside there to inside this side over here. Otherwise, if this is diameter and the hole is diameter, you can slip this right through with no success of threading the nut in this area. Okay, so the hole will be much smaller. How much smaller? 0.1 of diameter. So 0.1 or 0.1 is 1.8 of diameter. So therefore I will go from that point 1.8 inwards, and from that point 1.8 inwards to give me 1.5, basically 2 millimeters smaller for the hole itself. Alright, so that's where we will start. Once we're there, we can start with the bottom piece of the nut. I know what the height of the nut is. The height of the nut will be basically 18 diameter multiplied by 0.8, so therefore it's 0.8 gives you 14.4. so I'm going to measure 14.4 upwards, and that will give me the height of what I need for that. So therefore I can project from the front view, from the top view towards the front view, the rest of the nut. Alright, so now we're going to go 60 degrees and we're going to draw the arc, strike the arc for this section over here where it makes the arc over here. I've got a smaller one on this side and a smaller one on that side. Pretty much the same principle will apply, where I will measure 60 degrees downwards, and where those intersection lines will be, I will be able to draw the arc for the smaller circle. Alright, of course I'm going to do the same on the bottom. There we go with the bottom part of it. Once I'm there, I can join up now those lines with each other to make the nut looks real. And then from the top and the bottom end, I just need to know that this area over here will be in some sort of way flanged off or tapered off to 30 degrees over here. So therefore I need to draw 30 degrees lines on that side, and if I go this way, it's also going to be 30 degrees to that side, and I can complete the nut in the front view. Alright, of course I can't start in the front view because I don't know what the distances are there. I have to start with this part over here to get the true shape, and then from there on find the front view. For the left view, it's simply just by projecting it over. Now just remember, now this is now edged off on 30 degrees and 30 degrees, but on the left view it's square. Why? Because this arc goes all the way up to the top and then goes downwards again. So this is actually an arc starting here, going up, and then from there downwards, and then on this side over here starting going upwards and downwards on that part over there. How do I get the arc or the size of the arc? Because I'm going to have now two sides with arcs over here. Same principle as what was applied for this part over here, is to draw those 60-degree ends in there, and then from there on use that intersection point for the size of the circle or size of the arc up to the tangent line. Now, very important, ladies and gentlemen, if you do make use of a circle stencil or a nuts and bolts stencil, remember that that must be a tangent arc towards the line itself, tangentially touch that area. There mustn't be a gap on those points at all. And then of course the bottom part of this part is exactly the same, and that's basically the left view without the final line that I have to draw in at that point. So that's the construction of a nut itself. Here you can see on the previous exam that I've showed you how many marks can be compiled for nuts and bolts itself. There's the nut over here on the top view. You can't of course draw the front view if it's not there, and then of course the size of it is very important. You get a full mark for the size, and then 30 degrees and 30 degrees, and then of course which part of the shaft or the nut, in this case the shaft, will be solid and which part will be broken. This is for the nut itself. The height of the nut is important. That's 0.8 of diameter. This will be 30 degrees, and these arcs needs to be drawn as tangentially on towards the line itself, and then the lines that going downwards as dark lines is all been drawn in this case. Alright, so there's the height, and then also the height or the hatching. There's no hatching on this part because you're not allowed to cut through the nut itself. Alright, so if I've got my machine part over here, now remember this is the top view, I need to drill a hole inside here. It means that this will be smaller than diameter if I drill this whole part over here. Then diameter will be from there to there. What's the distance in there? It's 0.1 of diameter, and the distance from there to there is also 0.1 of diameter, the same over here and on that side. So there we go. Hatching must go right through towards the hole like we have shown you there. There's some material in there where the thread is. Now if I of course put the stud like this one, place the stud inside the hole, diameter will be from side to side. The threaded part will be 0.8 smaller, so we can add this part. Oh yeah, first the washer, place the washer in, and then we can add this area of the stud, and then turn the bolt in on this part. I will get to that just now. Alright, so here we go with a lock nut. Now remember the height of this was 0.8 of diameter. With a lock nut, the diameter will change. For the size across flat, it's exactly the same, diameter multiplied by 1.5. Do the hexagon. From there on, this is diameter. The threaded part or the hole at the bolt will be 0.1 of diameter, so therefore it's 1.8, in other words smaller. Now we've got it there. We can say we can start with this part over here, and then instead of multiplied by 0.8 of diameter, I'm going to multiply it now with 0.5 of diameter. So that distance over there, because it's a lock nut, construction of a lock nut, it's only 0.5, so therefore I'm going to end up with 9 millimeters. So there we go with the nut. The principles of striking the arc is exactly the same. It's 60 degrees, and the smaller arc's exactly the same. It's also going to be 60 degrees, so there we go with that part. And then from there on we turn it around to do the edging on the bottom part as well. We're going to complete the sizes of there we go for that part over there, and we're going to edge it off on 30 degrees and 30 degrees, and then also on 30 degrees on the other side, and complete this. Now you can see it's much smaller because it's a lock nut, it's much smaller, and this is what you will get for the left view. Again, it's a rectangle. Again, you're going to have your 60 degrees on either side. You're going to strike the arcs on the top as well as on the bottom. You're going to complete that final line over there, and that's what it will look like for the lock nut. Now this is the purpose of the lock nut. The purpose of the lock nut is basically to add some nut and tightness towards this part over here, so it doesn't rattle and become loose in the process. So it's tightened up one against each other, and to make it stronger. So of course we don't need to waste money on thick nuts that we're going to use over here. We're going to make it smaller, so therefore we're going to save some money by adding a smaller one. And the diameter of this part, of course, is like we said with this part, it is, to get the height of this is 0.5 of diameter. In this case it was 9 if you multiply that with each other. Alright, so that is what you see in terms of constructing the lock nut. It's exactly the same as in constructing the nut itself, and the only difference is it will be much flatter than what it will be. Alright, construction of a washer. Now of course this is the washer, where the washer will fit in. If we take and drill the hole in this part over here of the material, of the metal, I of course have to put the thread inside there. So there we go with the thread. The thread will be diameter, and once it's there I will hatch all the way to the side of the hole. Then I'm going to add another piece of material on top because I need to tighten this part over here. So that broken circle that we have had is now covered with this hole over here. So therefore that is what we will see with diameter. So therefore that's a solid circle now. Once we're there, we're going to place the washer on top. Now the washer diameter will fit in onto this part from diameter to diameter. So therefore the washer will be placed in there. How big is the size of the washer? It's diameter multiplied by 2. So there's another formula that you have to remember. You multiply it by 2 to get the size of the washer itself, right? And then how thick will the washer be? It's 0.2 of diameter. So therefore it's 3.6 millimeters upwards. So this is easy. It's 2 times larger than diameter and 0.2 times for the height of diameter. And that's where we will have onto this part over here. And then of course I'll put the stud. There goes the stud inside there, and then of course I can put the hexagonal nut on top of that part. All the areas that's not going to be hatched is clearly visible. The stud is not hatched, so therefore no hatching anymore there. This is the hatched area of the thread, the hole that's been drilled in, washer being placed on top, and then the nut that has been placed on top of this part over here, and then that part of the stud that's still standing out. Now this portion over here is tightened up by all of this that has been turned into this part. Again, with washers, there's the half a mark for the washer, and then over here the height of the washer, and also the width. So you get marks for all of these calculations that you do get. Construction of a bolt, ladies and gentlemen, this is the bolt. Again, we work with diameter, and like in the case of the stud, we're going to work with 1.5 of diameter for the cross flat. So we're going to take diameter for the height of it, for the height, it will be 0.7 and not 0.8 like in the case of the nut. For the bolt it's 0.7. There's already lots of material in here. It makes it stronger, so therefore it don't need to be as strong. So therefore it's only 0.7 and not 0.8 like in the case of the nut. Okay, and then from there on, thread is still 0.1 of diameter. So there we go with this, with the bolt itself. Across flats will be 1.5 diameter, so therefore we draw the circle in there, we draw the hexagon, and then from there on we go downwards for the shaft, which is diameter in this case, and then for the thread it's 0.1 of diameter, so it's 1.8 millimeters inwards to get the thread parts. Get a starting point for the top, for the front view itself. The height we set is 0.7 of diameter, so 0.7 multiplied by diameter gives me 12.6. So off we go with that part. Once we're there, we can complete the bolt, the arcs. There we go with the arcs, and then also do the smaller portions of the arcs that you will get in that case. So therefore, there we go with that part over there. Now it's not necessary to edge off this part that's going to be part of the metal, so it's flat there, nobody can injure or hurt themselves against those ends over here, but on the ends over here it should be edged off. So therefore we still need to have the 30-degree lines over here that we have to fit in on that side and also on this side, and we can complete this part by completing the lines on the top and the bottom. Alright, so there we go with the bolt, the head of it. Now of course the threaded part of it, that is where we will join that part, that's diameter. And then very important, if we go for the threaded part, that's also going to be 0.1 of diameter. So in this case it's also going to be 1.8 upwards as well as 1.8 inwards on this side to get the sides of that part. That is going to be 45 degrees. Important to understand that this is 45 on here. This edge over here, that's 45. On this edge over here, it will be basically then turned into 60 degrees and 60 degrees on this side as well. That's where your thread with the die you're going to use will gradually end up by 60 degrees on that point over there. Alright, so this is what you will see in terms of the front view. On the left view, as in the case of the nut, this area over here is square and square or rectangular if you see it that way, but it makes a 90-degree corner, and we're going to do the same as what we have done with the arcs on the front view. We're going to fit the arcs in on the top view as well. Alright, so then this portion will be exactly the same on either side, so therefore we can add that exactly the same as this part. 45 degrees there, 60 degrees over there. Alright, so if you go to this portion, now it's turned in from top to bottom. There you can see the 60 edges over here. You can see the 45 edges over here. The die that's been used to cut the thread into the block over here is also 60 degrees. And then the drill has been sharpened on 30 degrees on this ends over here. So that is 45 degrees for the stud, top and bottom, or for the bolt itself. And then over here you can see the examiner is giving marks for all of these that you have determined. Was asked in 2019, 2018, 2017, 2016, 2015, and so we can carry on. Nuts and bolts and top ends, it's always important to indicate. So that's my 60 degree for my die. That is basically cutting the thread in here, and then yes, seen from above, solid on the outside, broken circle on the inside. Then over here again, 45 degrees, the distance over there, 60 degrees, solid line, and then the examiner gave this information to draw this upper part over here, which was asked in 2019. Right, hatching is important, not to go over the hatched lines. Here you can see the sump plug that has been turned in, no hatching on the side. From there further onwards, the hole is still open and the thread goes up to the end, so therefore the hatching goes in there. So this portion and that portion. Ladies and gentlemen, just before I close out this area, just remember for 2019, about 50% of the exam paper was asked nuts and bolts and thread and threaded areas and hatched areas and not hatched areas. So it's very important to understand the construction of nuts and bolts if you get to this point. We have done this portion, so I'm going to go out here. I've also explained to you this part of the question paper where all the information was given. And then this is the memo of this question. There we go with the memo part of it, the upper part and the bottom part. You can count yourself if you have got this access to this exam paper. If you total up all these nuts and bolts features and washers and threaded areas and hatched areas, 50% of this question paper consists of nuts and bolts, and the rest was basically then for the components. Alright, so it's very important to understand and to know the difference between all of this. This is now for grade 11 level. You can see much less components, but again, it's pointing out no dimensions for the nut. It's pointing out some of the dimensions for the stud itself, and with this stud, it's just pointing out to you the area where how far it's going to be open, closed and open for thread and for cleaner areas, and the diameter. So this, all the dimensions you have to know by formula, what the height of it is, what the cross flat should be for that, what the size of the thread will be in over here, as well as in on that side, as well as on the top and on the bottom part. So all of that information is subject knowledge. You can see there's only 3 components, one component for this base part, and then that part fits onto this part over here, and then you get a washer. The size of the washer also not given, it's not even shown to you, it's just pointing out to you here on this bottom part over here, that the washer is not shown and it's made out of soft steel. You should know what the dimensions is for, from diameter of the size of the washer, the size of the bolt. So therefore this is very important to understand where did it come from, and then of course all your formulas according to that part. Alright, so this is the question paper. Now this is the memo for this specific question paper. You can see how much marks will be counting for washers, for the stud itself, standing out on the top, standing out on the bottom, the 45-degree edges. You can also see the nut on this part, the nut on that side over there, the size of the circle of the washer. You don't get your mark if it's just drawn there. It must be the correct size, only if it's basically then 42 millimeters and the washer is 56 millimeters, and so on and so on. Alright, so that is very important to do all those calculations 100% correct and to understand the formulas. Alright, some other questions I want to point out to you in this regard. That's the question papers of the assembled drawings. Now, of course, it won't end up with those type of 4 or 5 components. It will end up with a drawing like this one over here, where there's lots of components. Now I can basically end off this session by showing to you the questions that will be analytical questions, as well as questions that will be forming part of the assembled drawings. You can see over here, this is the typical mechanical analytical question, where they ask you some questions over here. How many parts make up this? You can count them all here, but now remember there's some parts on the other side or the back part that's not visible. So it's of good advice to maybe go and count the quantity here on the bottom over here. Then also material is made for the gasket. Now there is the gasket over there in between. Now you can't see the material on the drawing itself. You have to go here and see that it's made out of cork, for instance. Alright, the scale is indicated. It's on the name block over here on the bottom. Then also what is visible at F. Now if you go to F, it's over here, it's break of continuity, or it's been etched off to indicate, let me just quickly open up the memo over here. Sorry, I just want to go to this one over here. Over here it's interrupted view. You can see that this is interrupted in the process. And then also what is the date of the revision. Now that you will find in the name block over here, revised by and when it was revised, and then also what was the reason for the revision. It was to add a gasket. It says everything here in the revision part of it. And then also if you go further downwards, you will see it's what's the drawing number, what is view 2B called. Now remember, this is third angle graphic projection, so this is front view, so the top view will be placed on top, so that will be view 2 will be the top view in that case. Name this section at 1, okay, at view 1, okay, so name the section view at 1, so therefore you have to write down the section view. It's section front view on AA over there, right, of which you will do in later, right. Then also they ask for the section view, how many custom made nuts are there. You can count them here, but it's more accurate to go and count them here on the bottom over here, where it points out to you nuts, soft steel, and it's pointing out there's 4 of those, right. So that's the nuts that you will have, so it's 4 of them. And then also the diameter of the dimension of the collar. Now there's the collar. You should know what a collar on a shaft is. This is the collar on the shaft, and what's the dimension? It doesn't show here by G, but if you go to this part over here, it's radius, but they're asking for the diameter, so therefore you have to multiply by 2, so it's going to be 64 for the diameter of the collar itself, Right, so the answer is not always at G and at C and so on and so on. It's some hidden behind. Over here, asking the total width of the flange. Now width is from left to right. This is the flange part only, this portion over here. It's not the complete part, this is the flange. So the flange is 100 millimeters, although it's much shorter over here. It points out, it carries on to that direction. So it is 100 millimeters plus the 16. So from there to there, that is actually the complete length of it. So it's 116, the answer should be. All right, ladies and gentlemen, the total height is the next one. They ask for the height of in the front view. It doesn't show the dimension, but remember this is round. It's a diameter, so it's the same as that one over there. So the total height will be 130 in total. That's what it points out to you. Diameter 130, so the total height will be 130 millimeters. All right, and then the name of this drawing you can find in the name block over here, and then they ask over here to draw the freehand third angle geographic projection system symbol that's been used. So that is what is being asked in this case over here. Another question, it was this question over here, and here they ask all the conventions. Where will you find knurling? Now knurling is over there, so it's at number 4. So you write down number 4 over there. Where can you find the stud? Now that is the stud itself. That is the bolt. So this one, number 9, is the stud itself. And then where can you find a pin? The pin itself, that's the pin that goes right through. That's at number 11. So therefore you will write down 11. And everything was asked: the washer, the web, the bolt. Where can you find a web itself? This is the web part over here. Partly sectioned area where it's just partly sectioned. Now there's 2 areas. That is a partly section over there. There's another partly section. So there's actually 3 areas. But then this one at number 12, that is partly section. So there's no numbers over there. So you can't give that as an answer. It has to be number 12 as the answer itself. So all the conventions, all the sans symbols, everything we have done up to so far with the 2 sessions will be combined in a question like this one over here, and eventually ask me some questions in terms of that. So therefore it's important to understand analytical questions. It's important to understand analytical questions over there, as well as mechanical assembled drawings, which is this drawing over here. Now yeah, ladies and gentlemen, thanks a lot for listening. I really appreciate your attendance, and I really appreciate, and I hope that this whole complete combination of 2 sessions that we have had will be combined in order to find yourself a suitable space for how to answer all these questions and how to answer the assembled drawings as well as the analytical drawings in terms of mechanical drawings. And I really sincerely hope that this session helped you a lot. I thank you very much for attending.